Hi, my name is Akshay and I'll talk about my term paper. These are the papers I have critiqued. I've implemented the first paper and I'll talk about it in detail in a while. The second paper is based on reinforcement learning and the third paper is based on developing something called generalized MM. MM is a technique for developing or designing optimization algorithms, and this paper builds upon the existing theory of MM to develop a new technique. So let's discuss the first paper, which is called Power K-means clustering. It's from ICML 2019. Lloyd's algorithm for K-means clustering is currently the most popular clustering algorithm because of its speed and simplicity. However, Lloyd's algorithm suffers from some well-documented disadvantages like initialization sensitivity and the curse of dimensionality. So the authors of this paper have proposed an alternative which retains the speed and simplicity of Lloyd's algorithm and simultaneously tackles the disadvantages. This algorithm, called Power K-means algorithm, is similar to Lloyd's algorithm in the sense that it's an iterative algorithm and it alternates between membership reassignment and cluster recentering for minimizing an objective function, which is what happens in Lloyd. However, the way in which these operations are done is different here. There are specific functions which cater to these operations, and these functions are derived from the power k-means objective function using the theory of convex optimization and majorization minimization. In the power k-means objective function, this term S is called as the power or exponent of the objective function, and theta, the capital theta, is the cluster center matrix, and the job of this algorithm is to find out theta star, which will minimize this objective function. This is the actual algorithm. We perform some initializations before we run the algorithm. Specifically, we set the value of the power or exponent of the objective function to be less than 0. We initialize the cluster center matrix and we set this constant eta whose purpose will be explained in a few seconds. After the initializations, the iterations are done. In every iteration, first we perform the membership reassignment task in step 3, followed by the cluster recentering task in step 4, and finally we perform something called annealing, in which the power of the objective function is increased or changed by this relation. So eta here is this is where the term eta comes into play, and its purpose is to speed up convergence. It's not strictly necessary, but it's strongly recommended to do so. Uh, so these are the results of running the power k-means and the Lloyd's algorithm on a simple 2D data set of 4 clusters. So we can see that even after 300 iterations, Lloyd's algorithm failed to converge because it got stuck in a local minima, whereas the power k-means algorithm converged globally within just 7 iterations. This is a pretty trivial example, but it can be shown that the power k-means algorithm works equally well in more complicated datasets. There are several avenues for future research. Specifically, the effects of the annealing parameter and the initial power on convergence is yet unknown, and hence these effects could be studied for speeding up convergence. And secondly, the generalized MM technique, which is the topic of the third paper I have critiqued, could be used to develop a better power k-means algorithm.